This is the second video for section SEQRG. In this video we're looking at the recursive formula for arithmetic sequences. Now, as arithmetic sequences are generated by adding a common difference to successive terms, the recursive formula for arithmetic sequences is defined by this here. So if a1 is my first term, then my next term, ak plus 1, is going to be a to the k, whatever the previous term is, plus d. Okay? So, for example, given an arithmetic sequence's first term is 39, so a1 equals 39, common difference is negative 5, find the recursive formula and list the next two terms of the sequence. Okay, so from here, if a1 is 39, then a to the k plus 1 has to be my previous term, which will be a to the k, plus my common difference, which will be minus 5 in this case. Again, for k is greater or equal to 1. So we're listing the next two terms. a2 is going to be a1 take 5, so 39 take 5, which is 34. And a to the 3 is going to be a2 minus 5, which is going to be 34 minus 5, which is 29. Okay, so my key pieces of information I'm underlining. Next, an arithmetic sequence has a sixth term equal to 5.2 and a common difference of 3.4, and it wants the recursive formula. To be able to do that, I need my first term, so an equals a1 plus n minus 1d. Plug in what I've got. I want a1, so I want a1, but I actually have a6. So a6 would be a1 plus 6 minus 1 times my d, which is 3.4. a6 is 5.2, so it's going to be a1 plus 5 times 3.4. So 5.2 equals a1 plus 5 times 3.4 is 17. So I can take 17 from both sides. So a1 ends up being negative 11.8. Okay, so the recursive formula is going to be that a1 equals a negative 11.8, and ak plus 1 is going to be a to the k plus my 3.4, my d, for k is greater than or equal to 1. Okay. Next, if the eighth term of an arithmetic sequence is 35 and the 15th term is 63, determine the recursive formula. Well, I need a1 and I need d. So we're going to use simultaneous equations, very similar to questions that we did previously. So my formula is that an equals a1 plus n minus 1 d. So for my a8 I would have a1 plus 8 minus 1d, so 34 equals a1 plus 7d. For my 15th term I'd have a1 plus 15 minus 1d, so 63 is a1 plus 14d. I'm going to rearrange this here to be a1 equals 35 minus 7d, so I just took 7d from both sides to get a1 on its own. Equation 1, equation 2, I'm going to sub 1 into 2, and I get 63 equals 35 minus 7d plus 14d. I'm going to take the 35 from both sides, so 63 minus 35 is 28. Negative 7d plus 14d is 7d. Divide both sides by 7, I get d is 4. Sub d equals 4 into equation 1, and I get a1 is 35 minus 7 lots of 4. So 35 minus 28 gives me 7. So my recursive formula is going to be a1 equals 7. ak plus 1 is going to be ak plus 4, for k is greater than or equal to 1. Okay. Next, an arithmetic sequence is defined by the recursive formula given. How many terms of the series must be added to result in a sum of 246? So I've got A1 is 4, I've got AK plus 1 equals A to the K plus 3. Just trying to write my information out. Again, K is greater than or equal to 1. So A1 is 4, common difference is 3, Sn is 246, and I don't know what n is. Write out my formula. Sn is n over 2, 2a1 plus n minus 1d. Plug in. 246 has to be n over 2, 2 lots of 4 plus n minus 1 times 3. Times both sides by 2 to get rid of this 2 here. So I'm going to have 492 equals n. I'm going to neaten up what's inside my brackets. 2 4s are 8. And I'm going to expand here. N minus 1 times 3 is going to give me 3 times n is 3n. 3 times negative 1 is minus 3. So neaten up. 492 is n. Bracket A. 8. Take 3 is 5. So I got 5 plus 3n. Expand my brackets. 492 equals 5n plus 3n squared. Get everything to one side. I get 3n squared plus 5n minus 492. Now by using factorising or the quadratic formula, whichever way you want to do it, I'm not going to do it here because we did that in the quadrat module. So quadratic formula, I assume the majority of students always choose it when solving because I don't have to think about factorising. You get n equals 12 or negative 41 over 3. But n must be positive, so therefore 12 terms must be added. Okay? Quite a nice little question. You might want to pause and try and do that one again yourself. Next, complete exercise SEQRG2 of the textbook. Quite a few questions there for you to practice.